Okay, week 3 for Math Activate warm-ups. Question number 1 is really a question you just draw out and think through as long as you know what the words mean. It's not too bad. For how many whole numbers from 44 through 55 is the ones digit greater than the tens digit? So let's start off drawing 44 through 55 because it says from 44 to 55. It doesn't say between 44 and 55. So we are using the 44 and using the 55. Okay, and it says the ones digit has to be greater than, it doesn't say equal to or greater than, just greater than the tens digit. So ones digit greater than the tens digit. So this is our tens digit, this is our ones digit, okay? So that one's not greater. Here the one is bigger, the one's bigger, all the way through there. Okay, once you get over here, the ones is smaller, equal, so none of those will work. So you have 5. Okay, number 2, the weight of a circular rod of a certain type is proportional to its length. Proportional should bring back memories of cross multiply and divide. Okay, setting up proportions. A 15-foot circular rod, we're going to set them up in ratios. 15-foot circular rod of this type weighs 35 pounds. Okay, notice I put the feet on top and I put the pounds on bottom. You have to set up your other fraction exactly the same order. Now, and we're set up a proportion, which is a ratio equal to a ratio. What is the weight? What is the weight in pounds of a 21-foot circular rod this type? Because they wrote it in that order, oftentimes many people will flip that and do x over 21, which is incorrect. You got to have feet on top, pounds on bottom, pounds on bottom. If I had the other one flipped, I could do it the other way. It would be okay to also set it up this way, okay? All right, so in a proportion, you cross multiply and divide. So 15 times x is 15x equals 35 times 21. Okay, so that's 735. And then to solve that, we're going to divide by 15. Most people don't even set up this equation. You're so used to cross multiplying and dividing that most people do 35 times 21, enter, in their calculator, and then divided by 15, enter, and don't even set up the equation, which is fine. So that would be 49. So let's think back and make sure this makes sense. 15 feet is 35 pounds, so it makes sense that longer or more feet would be a higher weight of 49, so that makes sense. Okay, number 3, 1985, the cost of clothing for a family was $620. In 1995, this was 1985. In 1995, which was 10 years later, the cost of clothing for this family was $1,000. Assuming the cost increased linearly, what was the cost of this family's clothing in 1991? Okay, so basically it's wanting you to plot 2 points, look at it linearly, and then find another point on it. There's a lot of different ways that you could think through this problem. I'm going to run you through 2 different options. One is very calculator-based and algebra-based. The other is more of a common sense base. It kind of depends on where you're coming from. You can, first of all, it's kind of like having 2 points. Let's say this is year 0 and this is year 10. So the first point would be 0, 620. The second point would be 10, 1,000. And one way to get a linear equation for these would be to put them in your stat, edit, and you know how that gives you your L1 and your L2 and your calculator? You would put the 0 and the 10 here, the 620 and the 1,000, and then you do stat, calc, and choose linreg. You should have done that a lot, math 1, math 2, things like that. So hopefully you remember those words. If you're not familiar, that's not a big deal. I'll show you another way. But once you do the linreg, it tells you that your equation would be y equals 38x plus 620. So from here, you've got to think about, if I have my equation, how do I figure out how much it would cost in 1991? So let's figure out if this is year 0 and this is year 10, what year is 1991? Because it's between there. And if you count them up, 1986 will be year 1, 1987 is year 2. This would actually be year 6. Okay, so for year 6, this is our years right here, and this is the cost. So y equals 38 times 6 plus 6. Did I write that right? 620? Yep. Okay. So when you multiply that out and solve it, you get 848. So that's going to be the answer. Let's run through extremely quick, a more common sense way to get it that doesn't use the calculator as much. If that year 1991 is between those 2 points, and if it's going up linearly, that means it goes up the same amount each year. So let's just do 1,000 minus 620 to get how much the money changed. And then when you get that, let's divide by 10 for the 10 years. And that gives you 38. That 38 means that every year the cost goes up $38. Because this is how much it changed over 10 years. And if you divide it by 10, that gives you the change over each individual year. So if it starts at 620 at year 0, and then we want to go up to year 6, you just add 38 each time. Okay, so you could figure that out on your own, just, messing with it instead of having to do it in the calculator and things like that. And it will give you the same answer of 848. All right, number 4, math homework assignment. Carla found the area and perimeter of a room in her house. She reported the area rectangle was 180 square feet. Okay, so area, so rectangle, it's 180 square feet. And the perimeter of that rectangle was 54 feet. When drawing a sketch of her living room the next day, she realized she had forgotten to write down the dimensions of her room. So what are the dimensions? So basically, think of a rectangle. It has a length and a width. And you do length times width to get area. You do technically length plus width plus width. You add all your sides together to get perimeter, but most of the time you just do 2 times your length plus 2 times your width. Okay, so here's the different formulas that she would have used to get these numbers. So we want to figure out how to get the length or how to get the width. In most problems like this, it's much easier when they give you dimensions over here just to plug them in and see which one works. Multiply all of these. See if when you multiply them, they give you 180. And if they all do, then go back and plug them all into this. Do 2 times 9 plus 2 times 20. See if it gives you 54. And you work your way down through there until you find the one that multiplies to give you 180. And then when you do 2 times 1 plus 2 times the other, it gives you 54. And that will be your correct answer. It's faster and normally easier not to mess up than trying to do all the algebra behind solving those literal equations. Okay, I've marked these 2 out because when I multiply them, it does not give me 180. And now I'm going to go back and take these 3 and plug in here. And when I do that, these 2 do not give me 54. This is the only one that when you do 2 times 12 plus 2 times 15, it gives you 54. And it multiplies to give you 180. So that would have been the dimensions of the room. Okay, last one. Basically a scientific notation problem. They want to know how much n is, which is based on how many times you move your decimal. So 1, 2, 3, 4. Okay, notice the decimal gets moved behind the 1. So it moved 4 times. The main question is, was it a positive 4 or a negative 4? And there's a lot of ways of memorizing this. The way I like to do it is, this is a very small number with 0.000. Anything small like this would have a negative exponent. Okay, anything that's a big number like this, if we were to move the decimal, make it scientific notation, that would be a positive 6. That would be 2.345 times 10 to the positive 6. I like to think of those positive exponents as meaning it's a very big number, and the negative exponents thinking of it being a very small number. That's easier for me memorizing it. You can memorize the directions you move the decimal also if you would like to do that. All right, see you on next week.